The client's company, called as Nessus Company Sdn Bhd, established in 2015 and specialized in electrical vehicle, where the HQ is located in Shah Alam, and the client also have existing branches like SMT Bank in Kelang, logistic warehouse in Seremban, service center in Bangi, and dealership in Petaling Jaya. And the goal of this client is to create a new corporate office branch inside Berjaya, where the total workforce, including HQ, existing branches, and new branches, will be 918 employees.
For the Cyberjaya office, the Sdn Bhd has highlighted several key requirements. First, they want a reliable and stable internet connection that support all 350 employees across the 5 floors. Next, secure communication with their Shah Alam headquarters is essential, especially for shared system and collaboration. Since departments like HR, Finance and R&D deal with sensitive data, strong security and access control are a must. They also want full Wi-Fi coverage throughout the building, including open area, department and meeting room. The network must support critical applications like ERP system, HR platform, and video conferencing tools. They expect the design to be scalable to support future growth. As part of their great initiative, they require energy-efficient network hardware. Lastly, the IT team should be able to manage and monitor the network easily using clear tools and documentation.
To begin with, the network design focuses on performance, reliability, and availability. We'll deploy gigabit Ethernet switches with a fiber optic backbone along with VLAN segmentation and QoS policies to ensure smooth connectivity, especially for VoIP and collaboration tools. For reliability, the network includes redundant switches, routers, and UPS units. We also follow standard cable management and apply proactive monitoring and firmware update to maintain stability. In terms of availability, we'll implement a dual WAN setup with auto failover between ISP, as well as high availability configuration for key devices. VPN access will also support remote operation. On the security side, we are enforcing next generation firewalls, a DMZ for external facing services, VLAN isolation, and intrusion prevention system. IoT devices like CCTV will be placed in restricted VLAN, and wireless security includes WPA3 encryption and 802.1x authentication integrated with Active Directory. Scalability is also addressed through modular switches and scalable wireless access point and an expandable IP scheme, making it easy to grow the network with future needs. For manageability, we'll use the centralized tools like SNMP and syslog with remote access via SSH and secure web interface, along with full documentation and regular backup. So what we have here is our topology. So we have two different ISP. One is Time and one is Maxis. Time Internet is our primary internet, our ISP. And meanwhile, Maxis is our backup. In case Time Internet is having a problem of maintenance, we will be using Maxis as our backup plan. Both of them are connected to our router, and it is connected to our firewall. This is our branch firewall, and it is connected to our HQ firewall. And this is to the DMZ server. So the public will access only to the DMZ server. And this is the core layer of our system, of our topology. It will connect it to each floor, and in every floor we will be separated by different departments. So this is custom service, corporate, gas VLAN, IoT device, level 1, level 2, and then level 3. And then on level 4 we have this internal server. Every devices will connect it to the internal server only, and each department cannot access to a different department. So let's say we try to ping internal server from IT department. So we go to command prompt and then we ping. So this means the connection is successful because we have zero loss. Let's try on a different level. So let's open command prompt. Let's try to ping the internet server. Ta-da! Zero loss. So what if the HR department trying to access the admin? It says that the destination host is unreachable, which means you cannot access to a different department. Next is wireless technology. Finally, our wireless network is based on Wi-Fi 6 technology, which offer high speed, low latency, and support for dense environment. We'll deploy a dual band APs on all 5 floors, strategically placed to ensure an uniform coverage in both open areas and closed office. In short, this setup ensures fast, secure, and future-ready connectivity for all departments.
This logical topology, we focus on the network's IP structure and service flow rather than the physical layout, where we include information on the topology such as the VLAN ID and subnets for each department, the file gateway, and the HTTP IP range, where we also include the key service that we use for each VLAN. Site IP address, we also focus on the VLAN segmentation in the logical topology, where the VLAN actually assigned based on the organizational function and rule. Moreover, we also use VLAN tagging and key, where we implement IEE 802IQ standard to support multiple VLAN across different floor and switches. Moreover, we also use DHCP scope to automatically assign the IP address to endpoint device within each VLAN, and this eliminates the need to manually configure each device. And there's also certain IP addresses within each VLAN that reserved for critical devices such as server and camera. And there are several network services that we use, such as QoS, access control list, RPAC, and VLAN isolation for IoT and guest device. For DMZ network, we utilize treaty architecture to enhance the security and isolate the public-facing service from the internal enterprise network. The table shown is the VLAN and IP addressing table for each department or service. We also have DHCP scope table for each department or service, where 1 is for the gateway, while the number 2 until 9 is the reserved IP address for critical device. For example, for the level G, we have customer service with VLAN 17, corporate communication with VLAN 18, guest Wi-Fi with VLAN 100, and IoT device with VLAN 110. As for the level 1, we have logistic department with VLAN 15, warehouse department with VLAN 16, and also research and development department for VLAN 19. Whereas in the level 2 of the company, there is an IT department with VLAN 10 and the finance department with VLAN 14. As for the level 3, there is a HR department with VLAN 20 and admin department with VLAN 30. Now, as for the internal server with VLAN 200 and the MZ server with VLAN 150. And this is the three tiers related to the DMZ architecture, where it involves internet, DMZ, and internal line, the internet from the internet service provider to the micro router and then to the firewall, where it becomes as the public traffic entry from the ISP, while the DMZ from the firewall to the Cisco switch 9300 and then connect to the Cisco switch 9200, which then connect to the DMZ server, where this DMZ server hosts all the server like web, DNS, FTP, and email. We also have internal line from the firewall to the Cisco 9500 core, and then it will connect to the all VLAN in the network.
Next is the internet-working devices that we use for the Cyberjaya network. So the devices used are router, the Cisco Catalyst 9500 for the core switch, the Cisco Catalyst 9300 for the distribution switch, the Cisco Catalyst 9200 for the access switch, the firewall, the wireless controller, and lastly the access point. So the total estimated device cost for this network is 211,200 ringgit. Next, we move on to the LAN technology. So we use the Cat6 Ethernet. It is used to connect the computer, printers, and wireless access points to access switches. And we also use the Cat6A Ethernet, and it is used for faster connections between the main switches and servers. And also use the fiber optic, which it is a backbone cable for core level connections. And lastly is the power over Ethernet, PoE, and it sends power and data through one cable, and the usage is on the power wireless access points on every floor and reduce the need for the extra power cables. This is the one topology for the Nexus company, in which it uses two ISPs, which Time as the primary link and Maxis as the backup link. So it is to ensure that the HQ Insha Alam stays online at all times. Both ISPs connect to the firewall HQ, which protects the network and manage the traffic coming in and out. So from there, the firewall HQ is connected to the MikroTik router, which it is part of the LAN HQ network. And the firewall HQ also connects to 5 other firewalls, which this represent for each branches. For Cyberjaya, Klang, Bangi, Petaling Jaya, and Nilai, it uses either IVPN or VPN tunnels. These firewalls act as the entry points to each branch's internal network. So overall, this design gives the company high availability, better security, and a clear separation between the WAN and LAN, and it also makes future expansion easier. Next is the one service provider and technology. As said earlier, we use the Time and Maxis. Time is managed by the IVPN with a bandwidth of 500 megabit per second, and the provider is from Time Internet. The features and functions for Time are it have MPLS, multi-protocol label switching, in which it use labels to send data quickly and take faster path across the network. Next, it have VRF, virtual routing and forwarding. It keeps different types of traffic separate, and each service can have its own route that will improve safety and organization. The key advantages for the Time is on security, performance, QoS, quality of service, and monitoring. For the backup link, we use the Maxis with technology GPON, Gigabyte Passive Optical Network plus IPsec with bandwidth 1 gigabit per second, and the provider is the Maxis Business Fiber. The features and function for the Maxis is it have GPON, which it uses the fiber optic internet that uses passive splitters and good enough for normal operations and backup. And next, we have the IPsec, which it adds encryption and safety when using public internet. The key advantages for Maxis is on redundancy, security, and cost effective.
As for the security for the client's network of these new branches, there are several security layers that we apply, such as the first layer, VLAN-based segmentation, that serves as a foundational boundary for isolating the traffic between departments or service. And at the second layer is access control list, which utilized at the distribution and the core layer to further enforce the traffic segmentation. And at layer 3, there is a firewall implementation, which is responsible to manage DMZ access, guest VLAN isolation, IoT, VPN terminal to HQ, and protect the network of Cyberjaya branch from enemy threats. And at layer 4, it is related to DMZ architecture, where it used to isolate public-facing service. The table shows the implementation of the access control list that being used for the client's network, and this table is the firewall security policy table that being used for the client's network too. At the fifth layer, we utilize network access control to ensure that only authorized user and device can connect and access to the network, and we also utilize RBAC to further segment the access based on the user role. And at the sixth layer, it related to the VPN connectivity, where the VPN configure on the FortiGate firewall to securely connect the Cyberjaya branch to the Nexus headquarters over the internet. And at layer 7, the security is we apply logging, monitoring, and alert system in the client's network. And it is the VPN connectivity architecture, where the VPN tunnel actually apply encryption and security parameter, where it utilize AES256 encryption, SHA-2 integrity, and DH group 40 or higher for keys exchange.
For Nexus and Berhad, effective network management is critical to ensure performance, security, and reliable across all 5 floors. We will propose using SolarWide Network Performance Monitor and PRTG to monitor switch health, bandwidth usage, and traffic pattern. These tools also provide visibility into VLAN, VPN, DNS, and DHCP activity in real time. To manage the Cisco catalyzed switches and wireless access point, we recommend using Cisco Prime infrastructure, while FortiSIEM or Splunk will be used for centralized log monitoring, helping detect threats such as brute force attack and unauthorized access. Additionally, protocol like NetFlow and SFlow will be enabled to analyze bandwidth per department and monitor usage in IoT, DMZ, and gas VLAN. Alert threshold will be configured such as 80% usage for warning and 95% for critical to allow proactive maintenance and ensure business continuity. Overall, the approach offers a secure, scalable, and centralized management system aligned with PDPA 2010 compliance and ready to support future expansion. To conclude, the proposed network design support over 350 staff across 5 floors using a structured layered model. It includes core distribution and access layers for better traffic control and easier management. Each department has dedicated switches, and high traffic areas like IT and finance are given more capacity. Security is improved by separating zones like the server room, IoT, and gas network. This setup ensures reliable daily operation and ready for future growth.